Subtopic number 2, which is on Ohm's law and resistivity. So in this subtopic, you should be able to state and use Ohm's law, and lastly, define and use resistivity. Okay, so what is Ohm's law? Ohm's law. Basically, Ohm's law states that the potential difference across a conductor is proportional to the current if the temperature is constant. Okay, so only if the temperature is constant, then it obeys the Ohm's law. Okay, so based on the graph here, the temperature will be constant, giving us the gradient to be the resistance value. Okay, so we can then calculate mathematically. We can write Ohm's law as this equation here. All right, so this is an example. This is a graph of ohmic conductor, for example, a metal. This is known as the conductor that obeys Ohm's law. Okay, so this one, they obey Ohm's law. Okay, so for example, semiconductor, carbon, and electrolyte, they are non-ohmic conductors, meaning they does not obey the Ohm's law. Hence, the resistance of this will only depend on the temperature. Alright, now resistance, the value symbol there are, so it is a measure of the component's opposition to the flow of the electric charge. Okay, dia mau lawan the flow of the electric charge. So berapa magnitude yang dia mau lawan tu, macam tu lah. Okay, so mathematically we can calculate that by using this equation here. Okay, where V is the potential difference, which is voltage, and I is current lah. Okay, so it is a scalar quantity with the unit ohm, ataupun kamu boleh tulis volt over ampere, but usually we just write ohm lah. Okay, so in general, the resistance of a conductor will increase with temperature. So if the temperature is constant, obviously the resistance will also be constant. Okay, so make sure you get that point here. So resistance increase with temperature, but if temperature is constant, resistance will also be constant. Okay, so that is on resistance. Now on resistivity pula. So resistivity is the specific resistance. It is defined as the resistance of a unit cross-sectional area per unit length of a material. Okay, so this is calculated using this equation here. So resistivity is a scalar quantity with the unit ohm meter. Okay, don't forget ohm meter. Okay, and then it is a measure of the material's ability untuk oppose the flow of an electric current. Okay, ini material's ability. Okay, this is the material's ability untuk oppose the flow of an electric current. So it depends mainly on the type of material and the temperature. Okay, so a good electric conductor will have a very low resistivity, and then a good insulator will have a very high resistivities. Okay, so meaning that untuk dia jadi electric conductor, it should flow easily. Okay, the electric current should flow easily, meaning less resistivity. Untuk good insulator pula, it should flow it shouldn't flow that easily lah. Okay, so difficulty in flowing of the current, so meaning it can be a good insulator. Okay, some of these are the materials and these are the resistivity. Okay, now conductivity pula, sigma, it is defined as the reciprocal of the resistivity of a material. Mathematically, we can calculate that using this equation here. So it is a scalar quantity with the unit of per ohm per meter. Oh, I don't know how to pronounce that. Okay, gitulah. Right, so yeah, that is on Ohm's law and resistivity. Okay, so in this subtopic, you make sure you are able to write what is Ohm's law, and then sometimes in PSPM, if it is subjective questions, they would ask you to draw this, and then yeah, so that is basically for Ohm's law and resistivity.